它刚刚好一定是你看到这个三角形，我都知道它是3个 diagonal 来，就知道它是对应到某一个特定的6个外边的端点，对不对？所以的一个三角形最后的那一款呢，就一个三角形对6个端点，任何6个端点呢又对一个三角形，所以你就说有 n choose 6那么多种情形了。那刚刚在之前一个例子就是一个顶点配2个那个 diagonal 的交界，如果你看到这种形的话，那你就知道2个 diagonal 交界那条边一定要是一个 diagonal 来的，对不对？因为它都是 diagonal 的交界嘛，对不对？所以它上面一定是这个一定是 diagonal， 那这个也是 diagonal， 这个也是 diagonal， 所以你就看到了，在倒数第2款的那种形的话，它一定是对应这3个 diagonal， 对不对？那你看到这3个 diagonal 的话，你就对应到外面的那个大的 polygon 的5个端点，对不对？所以呢，一个这样的三角形就对应5个端点，但是这一定是出现在这5个端点里面你才会算到，但是呢，你每次算5个端点的话，一算就算5个三角形，所以你就会有总共有多少种这一款就是5倍的 n choose 5，所以就是这样算出来的，好难，想通了就 OK 了。Okay, so let's switch in English. Okay, so let's try to do this problem. So we want to have our digit string, and then this string will have alphabet. Let's say 0, 1, 2, 3. And then we have some criteria. So these are the criteria. I hope to have the number of 0 plus the number of 1s to be even. I want that to be even. And that's all. This is the only restriction that I want. So how many different kinds of R-digit strings are there? So to do this, let's try 2 different ways. Okay. So actually, this is the way that I will try first, because this is for sure that I know it is correct. Method 1, we are going to use rule of thumb. We divide things by cases. So rule of thumb here says, so number of 0 plus number of 0 plus number of 1 is even. So there are actually 2 cases. Case 1, it is even 0 plus even 1. Okay. So this will give us a total number of even number of 1s and 0s. Is that okay? And then we will have another case. Case 2 is I would have odd 0 and odd 1. So these 2 cases are counting strings differently. So if we know how many R-digit string with even 0, even 1, and then if we know how many R-digit string with odd 0, odd 1, then we get the answer. Is that okay? Okay? So let's do case 1. So case 1, we will have the EGF of 0 to be what? EGF of 0 will be equal to what? What do we have? So we need to have even number of zeros. So I can choose 0, 0, but I cannot choose 1, 0. I can choose 2 zeros, and so on and so forth, right? One way to choose no 0, one way to choose 2 zeros, one way to choose 4 zeros, and so on and so forth. So it is, I hope you still remember, this will be e to the power x plus e to the power minus x divided by 2. Is that okay? Is that okay? And then it turns out that it is exactly equal to the EGF of 1. And then the EGF for 2 will be equal to the EGF for 3, and then it is equal to e to the power x. Is that okay? Good. So in case 1, the EGF that we can choose 0, 1, 2, 3, anything of this one will be equal to what? We multiply things, all of them together. Okay? So this will be equal to what? So this will be, so we multiply this one together. So it is like e to the power 2x plus 1 plus e to the power minus 2x divided by 4. Is that okay? And then I have this one multiplied by e to the power 2x. Is that okay? Is that okay? This is E0, E1. This is E2, E3. Is that okay? So this is equal to, e to the power 4x plus e to the power 2x plus 1 divided by 4. Okay. Let's leave it aside. Let's do case 2 here. Now case 2, what will happen to case 2? Let me see. Yes. The middle term. Thank you. So lucky that you picked the mistake. Otherwise it would be wrong. Yes, thank you. Thank you. So this is 2 here, and then this is plus 2. Thanks. Okay. So this is plus 2 of them. Okay. Thank you. Good. Okay, now let's try case 2. So case 2 will be similar to case 1. Case 2 will be what? So case 2, this time the EGF for 0 will be equal to what? This time we need odd. So believe me, it should be correct. So odd, it will be like e to the power x minus, instead of plus, minus e to the power minus x, you divide it by 2. Is that okay? So it looks like this. Okay, and then this is equal to EGF of 1, and then the EGF of 2 and of 3, they are the same, e to the power x. So in this case too, the EGF for 0, 1, 2, 3, this will be equal to what? If you trust the calculation, then this will be something like this. E to the power 4x minus 2 times e to the power 2x plus 1 divided by 4. Is that okay? Okay? And then what do we want? We want to get the x to the power r term here. We want to get the x to the power r term here, add them together, and then do something. We multiply by r factorial. So actually, we can actually add these two together to get the combined EGF for all the cases. So we can also have this one. So for case 1 and case 2 considered together, we will get this EGF. This is the final EGF that combines case 1 and case 2 together. You just add them up together. So if we add them up together, what do we get? We get, so this is a combined. This will be equal to, so we have 2 times of e to the power 4x, and then there is no e to the power 2x, and then plus 2 divided by 4. So doing some simplification, then we should have e to the power 4x plus 1 divided by 2. Is that okay? Okay? Good. This is method 1. So let's try method 2. So how do we do method 2? Okay, method 2. So method 2, let's try to get the EGF directly of 0 and 1 directly using some counting. Okay, I'll use the board here. So let's look at what is the EGF of 0 and 1 look like. Okay. So here, so this time I can use 0 or 1 in any way. Okay. And then what we are interested in is also the permutation. 0, 1 is different from 1, 0. The permutation is different. Okay, now, if I allow you to use, let's make it more general. Let's say if I allow you to use, let's say, a total of 4 symbols, each of them is chosen by 0 and 1. How many ways can we get a string that is of even length? Exactly of length 4. This will be going to be what? You can have 0, 0, 0, 0 all the way, right? 0, 0, 0, 1, 0, 0, 1, 0. You can actually have 2 to the power 4 ways, right? Okay, so actually there are going to be 2 to the power 4 ways to have a string of 0, 1 of length 4 that you can choose. How about length 5? How many ways are there that you can pick a string of length 5 made up of 0 and 1? Okay, naturally it is 2 to the power 5, but our restriction is that the number of zeros plus the number of ones has to be even. So in this case, 0. We cannot choose. Is that okay? So let's write down the EGF here. So there is going to be one way to choose no 0, no 1. It's just no 0, no 1. And it is valid because no 0, no 1 means that the total length of 0 and 1 is 0. Total number is 0. And then the 0 way to choose exactly 1, 1, 0 or 1, 1. Okay? And then, how about length 2? How many ways are there? There are going to be 4 ways, am I correct? 2 to the power 4. Right? 2 to the power 4, right? There are going to be 2 to the power, 2 to the power 2 ways to choose a string of length 2. Is that okay? And 0 way, length 3, and then 2 to the power 4 ways, x4, and so on. So far, if you are okay with this, could you please raise your hand? Okay, good, good, good. So this is about how we can use 0, 1, at which the criteria is that the total length has to be even. So for odd terms, they are all zeros. Now for even terms, because the arrangement of these 0 and 1s is important, 0, 1 and 1, 0 will be meaning differently. Yet, just like what? Just like within an R-digit string, let's say I know that this is 0, 1. Let's say I know that this is 0, 1. If I fill in 1, 0 here, and if I fill in 0, 1 here, it will mean different thing. Okay, so in that case, there are 4 cases that we should consider. So there's 2 to the power 2 ways that we should consider. Okay, so how about this one? So what is it? So can we simplify this? Well, if you are so familiar with e to the power x, this is like e to the power 2x. So let me write down what is e to the power 2x. E to the power 2x is something like this. 1 over 1 factorial 2x plus 1 over 2 factorial 2x squared plus 1 over 3 factorial 2x cubed, 1 over 4 factorial 2x 4. And this is actually equal to, this is e to the power 2x. Is that okay? This is so close. Look at this term. This term is the same as this term. So I put 2 inside. So this term is equal to this term. This term equal to this term. So it is like we are looking at e to the power 2x, but only the even terms. Well, we have done this before. So this is equal to e to the power 2x. We look at the even terms. Plus e to the power minus 2x divided by 2. This is the EGF of 0 and 1. Is that okay? Good. We now have the EGF of 0 and 1. We multiply with the EGF of 3, EGF of 2, then we should get the EGF of the combined things. So we multiply this, so So we multiply this. EGF of 2, EGF of 3. We will get the EGF of the combined things. And what is it? So we get the EGF combined. Will be equal to, we multiply e to the power 2x here, because this e to the power x, e to the power x. So we get e to the power 4x plus 1 divided by 2. Is that okay? And excellent. So we find that using two different ways, we get the same formula. So at least this is working. Okay. And then to get the x to the power r term is going to be easy. Oh, let's do it together. Okay, let's do it together. So we need to find the answer for this one. So the answer for this one. Okay, let me see. So the answer is. We have r factorial multiplied with the coefficient of x to the power r in e to the power 4x plus 1 divided by 2. Is that okay? Okay. Okay, in general, so what would that be? So this will be equal to what? This will be equal to e to the power 4x. So it's going to be 4 to the power r divided by r factorial for this part. Is that okay? And then you multiply with r factorial. So it is going to be 4 to the power r divided by 2. That comes from this one. And then plus, okay, plus what? Okay, plus 1/2 if r is equal to 0 and plus 0 otherwise. Does that make sense? Yeah, because for this function, 1/2, you just have 1/2 when you look at the constant term. But you don't have x term, you don't have x squared term, and so on and so forth. So for general r, that is r equals to 1, r equals to 2, you should not add anything. But on the other hand, if r is equal to 0, then you should have a 1/2 here. Is that okay? Does that make sense? Yeah, let's try. So when r is equal to 0, we get 1/2 plus 1/2. So it is equal to 1, correct, right? How about r is equal to 1? R is equal to 1, then we get 4 divided by 2 plus 0. So we get 2 strings. So we are saying that there are exactly 2 strings of length 1 with even number of 0 and 1 together. Yeah, what are they? 2 and 3, right? We can have a digit 2, we can have a digit 3. Is that okay? And how about this case? When r is equal to 2, then what will happen? R is equal to 2, it says that there's going to be 4 to the power 2 divided by 2, so 8 strings. Which 8 strings? Okay, so we can have, there are actually either 2 cases. Either it is made up of only 0 and 1s, or it is made up of 2 and 3s. Okay, so there are 4 strings that is made of 2 and 3s, there's 4 strings that is made of 0 and 1s, so 8 strings altogether. So it works, actually. Okay, one more exercise for you. Okay. Let me see. Okay. So here we have n boxes. So there are n boxes. Box 1, box 2. So the boxes are important. They are labeled. So this box and this box are different. Okay, so all the boxes are different. There are n of them. And then we have R balls to put inside. We have R balls. So the balls is 1, 2, 3, like R balls. And then we can put the balls inside these boxes. In this way, this box is actually very narrow. It's not like this, not like a fat box. It's rather like a tube. It's like a tube. Okay, so if you put the balls inside, there will be ordering among the balls. Maybe I'm putting a ball 2 here, I'm putting a ball 3 here, and maybe I'm putting a ball 1 here. So 2, 3, and 3, 2 will mean different things. Okay, is that okay? So we want to find out how many ways to arrange our balls into these N tubes. How many ways are there? Well, this could be a lot of ways. Instead, we want to show the generating function. So we want to practice. We are not going to ask you how many ways are there. We want to show that the exponential generating function for this case is equal to, so to count the number of ways of doing so, is equal to e to the power x times 1 minus x to the power minus 1, minus n. Is that okay? Can you get a reason why this is true? Well, this is difficult. Is it going to be okay? How about let me ask you to map this problem to the string problem, because we have practiced a lot of strings. Okay, so are we going to find an R-digit string or an N-digit string? Which is more suitable? Is it going to be an R-digit string or an N-digit string? Yeah, we can have R and N, right? We have 2 parameters there. One is the number of digits that we are interested. So this is the x to the power R term that we want to find. And the other is the alphabet size. Okay, so 0, 1, 2, 3, so 4 there. So here, we have R balls put into the box. Okay, to explain a certain scenario, how can one explain it? Is it an R-digit string problem or N-digit string problem? Well, I think both works, but the easier interpretation is R-digit. Okay, so for instance, in this case, I will call it this scenario. Let's say we just have 3 balls. And then let's say there are 10 bins. Let's say n is equal to 10. Let's say we have 3 balls and 10 bins. Then I will write down, okay, 1 has digit 10. 2, it has digit 2. And 3, it also has digit 2. Is that okay? Well, but this one, we have problem because for this case, for the same case, let's say this is becoming 2, this is becoming 3, I will have the same representation for this. But let me worry this later. Okay, this is about counting this and that one differently. Is that okay? But here, what we can do is that we have R-digit strings in total. We want to figure out which one belongs to 1, which one belongs to 2, which one belongs to 3, which one belongs to 4, which one belongs to 10, and then get the exponential generating function for the case 1, exponential generating function for the case 2, and so on and so forth. Is that okay? Is that okay? Now, if we can do that, that would be great. Okay. Okay. So sorry about this. So I should not have EX here. So assume that all the R balls are used. It has to be used. Then what would happen? Then let's try to get the EGF for 0, EGF for 1. So what is EGF for 1? So EGF for 1, it means that if the strings has nobody choose 1, how many ways can we have? How many ways can we arrange things with 0 number of ones chosen? So this, I'll just write down 1, okay? Or x, okay. The different term is x squared, okay? So let's say when there are 2 items, we have 1. Let's say 1, and then let's say this is 1. They choose the digit 1, okay? How many ways can we arrange them? How many ways are there? So for our example here, when there are 2 things, I have assigned them to be equal to 1. I will count 2, 3 different as 3, 2. Does that make sense? So there are going to be 2 ways of choosing 2 ones. 2 ways of having 2 ones, okay? So EGF of 1, there are 2 ways of having 2 ones. So this is the term here so far. And how many ways of having 3 ones? So let's say this term is also 1. So that means what? That means I'm going to put 2, 3, and the ball R inside this tube. How many ways can we arrange this 2, 3 R that fits our criteria? How many ways are there? 6 ways. Is that okay? 6 ways. Okay. In general, how many ways are there? K factorial. Is that okay? K factorial. And this is exactly equal to 1 minus x to the power minus 1. Is that okay? If you are okay with this so far, could you please raise your hand? Yeah, sorry, it's overrunning. But I want to make one more. So one more variation, just a simple variation. So suppose that here we are assuming that all the R balls are used. All the R balls are used. But how about the case where, well, some of the balls we can just not use? So I want to still get the EGF for this case. This is going to be a new case. I have R balls. I want to put them into these tubes, N tubes. So I make it into N again. So there are N tubes. But then some of the balls can be unused. So we just leave them aside. Then what will happen? I'm claiming that the corresponding EGF will be similar to this one, but I want to multiply this with e to the power x. Reason, okay, I'll just tell you the reason. So if they are not chosen, let's assume that there is a box called box 0. Okay? So let's say the ball 1 is not chosen, the ball 4 is not chosen. Okay? Now my question here is that, does that matter of the arrangement between 1 and 4? Will 1, 4 be different from 4, 1? So 1 is not chosen. And then let's say 4 is not chosen. So it is not chosen. It corresponds to this string. It's not chosen. So this is not a tube anymore, right? 1, 4 and 4, 1 doesn't matter as long as 1 and 4 are together. Is that okay? So the EGF for this one is that there is only one way of having nothing here. There is one way of having 1 ball here, 1 arrangement. There is only one way of having 2 balls here. There's just 1 arrangement. If you tell me the 2 balls there, there's just 1 arrangement. So in that case, we get e to the power x for EGF 0. Okay, this is perhaps very difficult, but I hope the exercise today can get you familiar with this EGF. Okay, that's all. That's all for this EGF so far. And then next week we will talk about distribution of objects. Well, we still have EGF. Okay, yeah, but most of them is gone. Okay, if you can understand everything so far, then it's okay for you already. Okay, thanks a lot. Sorry for overrunning. Okay, and see you next week.